Hi everyone, in this video we are going to discuss about how to calculate the length of intercept of a secant line on a circle. Let's suppose we have a circle like this whose equation is x squared plus y squared plus 2gx plus 2fy plus c equals 0. That's the general form of the equation of a circle. And in that case the center of the circle would be at negative g comma negative f. And now let's suppose we have a secant line like this whose equation is ax plus by plus c equals 0. Here I am using the uppercase letters for the coefficients of x and y and also the constant term. Now if we have a circle and a secant line like this where we know the equation of the circle and also we know the equation of the secant line, we have to calculate the length of the PQ chord, which is actually the intercept of this secant line inside the circle. So that is our task in this video. First, I am going to drop a perpendicular from the center onto the secant line. Let's suppose the perpendicular landed at point R. The next little construction I want to do is I want to connect C with P. So CP will be the radius. And because CR is a perpendicular onto the chord PQ, if we consider PQ to be a chord which is actually part of the secant line, right? So because CR is a perpendicular drawn from the center onto the chord, R will bisect the chord PQ. That means R will be the midpoint of PQ. That means PR will be equal to RQ. And from here, then what will be PQ? Well, PQ can be written as the sum of PR and RQ, which can then be translated into PR plus PR, which is equal to 2 times PR. Now here, from the given equation of the circle and the given equation of the secant line, we have to somehow calculate the length of the chord PQ, which is actually the intercept of the secant line in this circle. So if we can somehow calculate the length of PR, then PQ will be 2 times PR. Now let's try to calculate the length of PR. First of all, what will be the length of CR? That we can easily calculate because we know the equation of the secant line and we know the coordinates of the point C, and CR is a perpendicular drawn onto the secant line. That means CR will be the distance of the line from this point. And using the formula of distance of a line from a given point, we can say that CR will be equal to modulus of a times x sub 1 plus b times y sub 1 plus c over square root of a squared plus b square. And in this case, x sub 1 and y sub 1, they are the coordinates of the point. And in our case, the point is actually the center of the circle, and we know the coordinates of the center from the given equation would be negative g comma negative f. So in place of x sub 1, I am going to use negative g, and in place of y sub 1, I am going to use negative f over square root of a squared plus b squared. Also, what will be the length of the radius of this circle? Well, because we have been provided with the equation of the circle, this is the general equation of a circle. From here, we know that R will be equal to square root of g squared plus f squared minus c. So I have noted that up there in white color. So now if you look at this little triangle CPR, that is actually a right triangle because CR is perpendicular on PR. So triangle CPR is a right triangle, and we can use the Pythagoras theorem, and we can say PR squared plus CR squared is equal to CP squared. And from here we can say that PR squared can be written as CP squared minus CR squared. From here, we can say PR will be equal to square root of CP squared minus CR squared. I am taking the positive value here because we are talking about the length of a line segment there. So we are taking the positive value. And now guess what? We have already calculated the length of CP, which is actually the radius of the circle. And that is, we know square root of g squared plus f squared minus c. And also we have calculated the length of CR. So let's just plug in the values here. We know PQ is equal to 2 times PR. Our ultimate goal is to calculate the length of PQ, which is actually 2 times PR that we have already shown. Now let's plug in the value of PR here. So we can write it as 2 times square root of CP squared minus CR squared. And next I'm going to plug in R in place of CP and the value of CR here. So it can be written as 2 times square root of R squared, that is actually the CP squared. In place of CP squared, I have written R squared, minus in place of CR squared, I have used the value of CR, and then I am using a whole square there within the square root, of course. And if we simplify this a little bit, we can write it as 2 times square root of R squared minus negative a times g minus negative b times f plus c whole squared over a squared plus b squared. Because we have a square there, we can get rid of the modulus sign easily, and also in the denominator the square root of a squared plus b squared whole square of it will become just a squared plus b squared without the square root, right? So this is the length of the intercept of this secant line on this circle. Now let's try to analyze if the secant line happens to be one of the axes. So we are going to take two cases when the secant line is the x-axis and when the secant line is the y-axis. So the first case is when the secant line is the x-axis. We know the equation of x-axis is actually y equals 0. And if we compare that with the general equation of the secant line, which is like ax plus by plus c equals 0, if we compare them, we can clearly see that a will be equal to 0 because there is no x term in the equation of the x-axis. So we can say a will be equal to 0 and b will be equal to 1 because the coefficient of y in the equation of the x-axis is actually 1. So we are denoting b as 1, and also there is no constant term, so c is 0. So now if we simplify the length of PQ here using these values, let's see what we get. So PQ is equal to 2 times square root of r squared minus, where we had negative a times g, I have used 0 in place of a, I have used 1 in place of b, where we had negative b times f, and also where we had plus c, there I have used 0 in place of c, the uppercase c. And then in the denominator, I have used 0 squared, so in place of a squared I have used 0 squared, and in place of b squared I have used 1 squared. Now if we simplify this, it is going to look like this. It will be 2 times square root of r squared minus f squared. And now let's plug in the value of r squared. We know r is equal to square root of g squared plus f squared minus c. So r squared will be just g squared plus f squared minus c. And then also we have a negative f squared there. So the value of PQ going to look like this. And then you see the positive f squared and the negative f squared, they will cancel out each other, and we are going to be left with 2 times square root of g squared minus c. So this is the length of the intercept of the x-axis on this circle. If the circle cuts the x-axis, then this will be the length. Now from here again, since we have a square root quantity here, we have to now analyze a little further, and we have to understand in what condition the circle could cut the x-axis or touch the x-axis or not even touch the x-axis. If the quantity inside the square root is greater than 0, then this value, the 2 times square root of g squared minus c, this value will be a real value. That means PQ will have a real length. That means the circle would cut the x-axis. So I have noted it here that if g squared minus c is greater than 0, then circle cuts the x-axis. Similarly, if we have g squared minus c equals 0, then the length of PQ will be 0. That means the circle will actually touch the x-axis. P and Q, they will be coincident. Their length would be 0. That means the circle is actually touching the x-axis. So for a circle to touch the x-axis, this condition has to be true, that g squared minus c has to be equal to 0. That means g squared has to be equal to c. And for the circle to cut the x-axis, g squared has to be greater than c. And now let's look at the other condition where g squared minus c could be negative. In that case, this quantity, the 2 times square root of g squared minus c, that will be an imaginary quantity. That means the length of PQ will be an imaginary length. That means the circle actually does not cut the x-axis, and also it does not touch the x-axis. It goes above the x-axis or below the x-axis. I hope things are clear up to this point. Next, let's talk about the second case when the secant line is actually the y-axis. We know that the equation of y-axis is x equals 0. And if we compare that with the general equation of the secant line, we can clearly see that a is equal to 1, b is equal to 0, and c is equal to 0. Because if you look at the equation of the secant line in this case, which is nothing but the y-axis, the coefficient of x is 1, coefficient of y is 0 because there is no y term, and also the constant term is 0 because there is no constant term. So from here we can say, well, if we use a equals 1, b equals 0, and c equals 0, we are essentially going to get the equation of the secant line as the y-axis. So let's plug in these values in the length of PQ, and let's try to calculate the length of PQ. PQ is equal to 2 times square root of r squared minus negative 1 times g, because in place of a I am using 1, and then minus 0 times f. In place of b I have used 0, and then plus 0, which is in place of c I am using 0, whole squared over 1 squared plus 0 squared. In place of a squared I am using 1 squared, and in place of b squared I am using 0 squared. And if we simplify this, we are going to get something like this: 2 times square root of r squared minus g squared. And next, let's plug in the value of r. We know the value of r is square root of g squared plus f squared minus c, and r squared can be written as g squared plus f squared minus c, and then also we have a negative g squared. So this is the quantity within the square root, and now you see the positive g squared and the negative g squared, they will cancel out each other. So if we simplify this, we are going to get just 2 times square root of f squared minus c. And here again, let's try to analyze the length of PQ depending on the value of f squared minus c. If f squared minus c is greater than 0, then we are going to get a real value for PQ, meaning a real length for PQ. That means the circle would cut the y-axis. If f squared minus c is equal to 0, that means the points p and q, they are coincident. That means the length of PQ is actually 0. That means the circle touches the y-axis. And finally, if f squared minus c is less than 0, then we are going to get an imaginary value for the length of PQ. That means the circle would neither cut the y-axis nor touch the y-axis. It will be either on the left hand side or the right hand side of the y-axis. I hope everything made sense. Thank you for watching. See you in the next video.